Hello and welcome. In this problem, we have a rigid tank which has H2O, water in it, at 30 degrees Celsius. And it's given that it's a liquid vapor mixture. That means there is some liquid water and vapor of it at 30 degrees Celsius. As it is heated to 330 degrees Celsius, we want to find the change in pressure. What is given about the final condition is that it still has some liquid inside it. So that means this is still a liquid vapor mixture, which makes the problem rather very interesting and simple to solve. So we want to know what is the difference in the pressure, P2 minus P1. All right. So because the mixture is a saturation mixture at both state 1 and state 2, the change in pressure is basically P2 minus P1, which is Psat at 330 minus Psat at 30 degrees Celsius. So let's see, we can pick up these numbers at 330 degrees Celsius and 30 degrees Celsius, the saturation pressure at a given temperature. So we go back to test and the property tables. This is a complete manual solution. So we look at the saturation temperature table, and saturation temperature table at 330 degrees Celsius, we pick up the number. As you can see, at 330, the temperature, the pressure is 12.845, and this is, by the way, in MPa, as you can notice. So million Pascal. So if we take this number and plug it in for P saturated at 330 in kPa, it will be 12840. And what is the value at 30 degrees Celsius? At 30 degrees Celsius, the saturation pressure is 4.246. So this will be, the answer will be in kPa, and if you find the difference, it is about delta P is about it's very close to 840. 12840 minus 436 kPa should be the correct answer. Let's quickly solve the problem using an app to verify that our answers are correct. So going to the test steps, if you go to the system states, PC model, and H2O is the default fluid. So we have H2O already. So we know the temperature initially was 30 degrees Celsius, and the saturated mixture means any value of X will work. You can pick 0 or 0.5 or 0.1, doesn't matter. It's a saturated mixture. So let's just find the saturation pressure, which we did before manually. It's 4.248 kPa, and for 330 degrees Celsius, again is a saturation mixture. The pressure is this. So in the I/O panel, we can find the change in pressure. Delta P in kPa equals P2 minus P1, which is calculated as 12840. So our answer is 12840 is the correct answer. So let me go and check what mistake we made. Okay, so perhaps at 330 degrees Celsius, it was a little bit more than this. So we can go back to the property tables. At 330 degrees Celsius, 12840. So as you can see, this is 5. And that's how we get the answer of this. So it goes to show that no matter how careful you are, it's always better to check your calculations. And the apps are available to make sure you don't make a silly mistake like I just did, picking up the number from the table 1284. I wrote down 0 instead of 5. But that's a pretty minor mistake. Percent-wise, the change in pressure that we calculated is very, very accurate. And the manual answer and the exact answer are almost the same.